Hello, thank you everyone for coming. My name is Michael Smart, Senior Support Specialist in the WRC, InterSystems Support. And today we're going to be talking about API design for REST with a focus on new features in InterSystems Iris. Let's do a little audience participation here. By show of hands, how many of you have created a REST service using an InterSystems product? Okay, good. It's about half, I would say. So this will be review for some of you at the beginning here, but I always think it helps to get a basis for where things stand right now with the technology before we introduce new features, especially ones where you have to change some of your thinking and some of your design patterns to take advantage of them. You might be familiar with this picture. It's a list of endpoints for a REST service having to do with coffee makers. And the way this works is when you create a REST service, you're building on top of a web server, on top of the HTTP layer. And there's code in Iris that is looking for certain requests that come in. And when we get a match for both the resource being requested and the type of request that was made, we perform some specified action on the server. Now, there's two types of code you need to write to make this happen. First, the interface, the way of dealing with the HTTP layer that you're built on top of. So doing things like taking parameters in off the wire and making sure the HTTP headers are set for the response. And the second type is the functionality, your actual application logic that you're providing with this service. Now, up until this point, there hasn't been a way to get around some of that redundant code, the interface stuff, that you'll find you need to write for each and every request. Unless you handle it yourself with things like helper functions, you're sort of forced to deal with this for each one of these endpoints. There also has not been a way to have some of this code be created for you automatically based on an external design document. All the code you write determines what the service both is and what it does. Now, is there a way to solve both of those problems to make the process of creating a service more efficient and have a better end result where clients can have more confidence in the service you're providing? Well, that's precisely what we're going to talk about today over the next 30, 35 minutes or so. We'll start with API design at kind of a high level, take a look at some core concepts so we can get an idea of how we can change our thinking to improve the development process. We'll then move into Swagger, a popular convention in the industry for describing the features of a REST service. And that's going to come into play in the two features that I want to highlight that are new to InterSystems Iris. First, there's the API management tool, which is a way to take a REST service you've already created and generate a Swagger spec, the description of its features. New to Iris 2019.1 is Spec-first development, a capability we're adding to actually go the other way, to begin your REST service as a Swagger specification and generate some code based on that. And we have time allotted at the end for questions, so please hold those to the end. I'm going to be demonstrating some code, a couple example Swagger specs, things like that through the course of the presentation. And those are all available right now, if you are curious, on our GitHub page at the repo API Design for REST. But keep in mind, as I said, the spec-first development will not be added until Iris 2019.1, so some of the things there will not be as useful as they could be just yet, but if you're watching this on video, Iris 19.1 may already be out, so I encourage you to take a look. Now, I did some thinking about how to begin, how to simplify the idea of API design to its most basic, fundamental concepts. And what I arrived at was this. There are two fundamental building blocks to the design of any API. Some things are spec. They describe what the thing does. And some things are code, the implementation of that design, how it does it. The relationship between these two pieces, and in fact the order in which they're created as you go through your development process, is kind of the crux of everything that I'm going to talk about. So keep these terms in mind as we move ahead here. Now, what is an API really but a bridge between two pieces of software? And that's represented by this consumer-producer model. You have a producer that's providing some functionality and a consumer that wants to connect to that to take advantage of it. And in the real world, these can be anything. You could have a Java program that you're writing and some third-party library that you're importing as one of your dependencies. This could be an ODBC driver and the database it's being used to connect to. Or for our purposes, a REST client and the service on the back end built with InterSystems Iris. Now we're going to find ourselves, I think most of the people in this room, from the producer side of things, developing a service. But let's take a look at the client side of things for just a moment. When you're developing a REST client, the service to you is kind of a black box. You don't know exactly how they do what they do, but your way into the functionality is through the interface that they've provided to you, the I in API. And hopefully they've given you some kind of description of what functionality is available so you know how to actually write your code. Things like, here are the methods you can call on my service and the arguments you're expected to provide. We're going to use these data structures when we communicate, so make sure that on the client you have a way to represent each one of those things. If I send you an error message or an error status code, that indicates that this situation has occurred on the server. So make sure the client code can account for that. So there's this idea of describing the functionality of the service in such a way that a client can come to you knowing nothing and get up and running with their code. And this is a great way to develop software. Client and server are kept separate as long as both sides adhere to that interface and the client has enough information. So how do we tackle this problem? In a lot of cases, the client and server will be developed by the same team or even by the same person. In that case, okay, out-of-band communication may be sufficient. You can imagine the email you might get. Hey, guys, that method you've been calling that took 3 arguments on Friday, it now takes 4 arguments, and we changed the order of them. So sorry about that. Make sure you keep your code up to date. But that's not going to work. That's not going to be efficient enough for the modern world, for this idea of microservices. As the number of services and clients connecting to them scales upward, we need to move a bit faster than that, because you may not even have direct contact with each one of your clients to provide them the information that way. But let's first take a look and see how you actually develop one of these things from scratch in Iris to get a sense of what information a client might need to know. What's the first step to create a REST service? You need to have a web application. The clients need somewhere to connect to. And the way we set up the web application for REST is by setting this parameter right here, the dispatch class. This means that when a request comes in, it's going to be dispatched to this class that you specify. And in that class, you're going to find this, the URL map, this little snippet of XML that looks rather similar to that table I showed you at the beginning. This is our list of endpoints that we're providing for the service. This is the interface that we're writing right here. If we get a match for one of these requests, we're going to call down into a class method and perform that specified action. Now you can see that whoever developed this service provided some comments for each one of these endpoints, some additional descriptive information. That's good. And there may be comments further down the line by the actual class methods that are being called. But this is all internal information. We need to figure a way to get this outside so clients can take a look at it. And the way I see it, there's 2 problems we have to solve here. First, how much information is enough for a client to know everything they need to know about a service? What things do they care about? Well, some clients may want different things, but as we said before, we can't deal with things on a case-by-case basis. So maybe a standards-based approach would be helpful to us. And second problem, what format would a client expect? What's going to be most helpful to them? We could do things the old-fashioned way and just type up documentation, maybe in Word and have some nice formatting and things like that. But how often is the interface going to stay the same? long enough for that document to remain relevant. We need to move faster than that. So maybe some automation would be nice to have if we could provide it. Now, the industry has tried to answer these questions in a number of ways, and one of the more popular answers at the moment is something called Swagger. And Swagger refers to something called the Open API specification, which is a format for a JSON document that gives all the information anyone would need about the functionality of a REST service, all the endpoints, all the parameters, these kind of things. Because it's JSON, it's designed to be human readable and machine readable. Okay. How do we get one of these things, these Swagger specs, if we already have a REST service? And the way you do that is the first new feature to Iris that I want to highlight, the API management tool. There's a REST service right here where we can make a request and get all the information we need. And I can demonstrate that to you right now with something called Postman, which, if you're not familiar, is a very helpful tool for testing and developing REST services. So I just pick what kind of request I want to make. And the response is a list of all the web applications on my instance that are enabled for REST. That is to say, they have a dispatch class defined. For each one of these things, there is a property called Swagger spec, and its value kind of looks like a URL. Well, if I make a request to this address, which is very easy with Postman, I just click. For this REST example application, here's the Swagger spec. This is generated on demand, on the fly, each time you make a request. We take a look at what's in the dispatch class at that moment and, taking all the information into account, boil that down into the Swagger format, as you see. Okay, so back to the client perspective for a moment. They've asked for this, the Swagger spec for your service. But what can they actually do with it? What benefit does this provide? Well, there are a number of tools in the marketplace designed to deal with Swagger specs, and because they're machine readable in JSON format, they can take that data and represent it in a number of ways. So here's one, for example, documentation with this tool called Swagger UI. You send in the Swagger spec, and it gives you this nice, interactive, colorful documentation instantly. And that's very simple to demonstrate. I'll just take this address from Postman that allowed us to retrieve the Swagger spec. Here's Swagger UI, and by default, it has this pet store service available. This is the popular example of a Swagger specification. And if I send in this address, that easy to get documentation for that service. I can click into each one of these endpoints and get additional information. Things like what parameters are expected when you make a request here. What types of responses can a client expect to receive in response? There's even this button here, Try It Out, which is a little mini testing tool if you want to make sample requests to the service. What else? There's another tool called Swagger CodeGen, which, when given a Swagger spec, can give you something called scaffolding code. And this is basically a way of abstracting the HTTP layer for connecting to a REST service. Swagger CodeGen takes the spec, and knowing exactly how to connect to each one of the endpoints, removes the need for you as the client developer to worry about things like setting up the HTTP request and making sure you're pointed at the right server and you've sent in the parameters in the correct format. It gives you almost this API on top of the API. Here's the Java example for that address book service that I just showed you. All you need to do is just pass in the various arguments to this method, and that's all taken care of for you. And you can update this generated code each time the spec changes, so you're always up to date on the client. Hang on to this idea for a moment, this idea of generating code from a Swagger spec, because we're going to return to this. But I want to now take another step back for a moment and talk about things from the design methodology perspective. Because doing things this way is referred to as code-first development, because as the name suggests, our REST service began as code. We just started creating our dispatch class, and that became the source of truth for the functionality of our service. You can generate the spec on demand with the API management tool, as I said, but it's an afterthought, right? It's literally a byproduct of the code. There wouldn't be any benefit to editing the spec independently of the code, although we certainly could. JSON is human readable. But we can't then take those changes and put them back into the code automatically. We'd have to go back and update the code again. Now, that's not to say that this is the completely outdated approach, and there's no reason to change. For some circumstances, doing things this way is ideal. If all you're doing is connecting two systems together using REST as your protocol layer, well, this can work for you. Or if the spec is not likely to change very often. Okay. But is there a benefit to turning things around and doing it the other way? Starting with the spec first, and then generating scaffolding code on the server side instead. Remember the original problem where we were faced with all that boilerplate code at the interface layer. Here's our solution for that with Iris 2019.1. It's a new feature. You send in the Swagger spec, we generate code for you for the dispatch class. As the spec changes, you can regenerate that code, and the plumbing is automatically connected for you. Doing it this way, the spec is now the single source of truth. No longer a byproduct, it's a first-class citizen in the design process. You can treat your spec as if it were code. Updates to the spec as you add and remove and change the endpoints can be tracked in your favorite source control platform. You could even have a situation where both the client and server-side development teams kind of weigh in on what the functionality of the service could be. For example, if there were a UI development team associated with your service, they might say, we need a new endpoint that returns this kind of data. OK, then we'll go ahead and add it. All those changes are tracked in source control, and you just regenerate the scaffolding code on either side. More than just a design document, doing things this way means that the spec is really a contract between client and server. The server is wrong if they're not adhering to what's in the spec. We promise to provide this functionality. If you send in a request with these arguments, you can expect to receive this in return. So we're not only building the thing right, we're building the right thing. There's a focus on how the service will be used. It's more of a consumer-driven development process. And then lastly, I think developing this way actually encourages something called test-driven development, which is kind of a buzzword, but it has become a popular way to develop software. And if you're not familiar, the idea is basically you set up unit tests at the beginning of your development process, checking the functionality of the service. Now, those tests will all fail because your service doesn't exist yet. But as you develop, you continue to run these tests until you get the all clear. And so now you have not only the confidence of battle-tested code, but also the confidence that you've adhered to the spec as it was outlined. So let's take a look at how we can actually develop a service this way. But first, we're going to need kind of a crash course in the Swagger format. We have to concern ourselves with what's in one of these documents now, because we have to write one. And there's a number of different fields. We'll start with the metadata fields, describing the service that we're about to describe. First is the version of the OpenAPI specification that will be used throughout this document, because that will be important to whichever process is going to interpret that spec. For Iris 2019.1, this will be Swagger version 2.0. Host and base path. Where is your service located? How do I make requests to it? What's the address? These are things that a client might need to know if they were looking at your spec independently of the server where your service is hosted. We also have an area to add some additional information, things like the title of your service, the version of the spec that we're looking at, very important for source control. Is there a software license associated with looking at the spec or using your service? Who do I contact if I have questions or need to report a bug? All very nice things to have. But the bulk of your work is going to be right here in this section called paths. Following the RESTful design principles, these endpoints are indexed by the resource name first and the HTTP method second. You're encouraged to reuse resource names when setting up a REST service. And so in each one of these ellipses right here, you're going to find additional properties that actually describe what that endpoint does. We have some fields for descriptive text. The summary field, which is the sentence-long version, and then a field called description, where you can be a little more long-winded. If you're familiar with GitHub and the markdown markup language that is used there, you can actually include some of that in the description field, and tools like Swagger UI will render that for you, so you can have a nice, rich text documentation. Operation ID. What is the unique identifier for this endpoint? This is useful for Iris when we're generating code because we actually use this to determine the names of the class methods. There's a list of the HTTP status codes that will be returned, or that can be returned from this endpoint. You can also specify the schema. If you're sending back data, what is the format? Can I look at that in kind of an abstract way? Parameters. Is there a parameter in the resource name, in the URL? Or do you have something like a post request where there's a payload being sent in? And what is the format of that? And then finally, a list of MIME types that are returned by this endpoint. So does your service support XML, JSON, plain text, so on? I mentioned schemas a few times. How do we describe the format of data going in and out of your service? And here's a nice way to do it. There's a section at the end of the Swagger spec called definitions. Oh, by convention, it's at the end. It could appear anywhere. But this is where you actually set up complex data types that are used by your service. So here's an example. We have an object called item. You could imagine this is an inventory service or something like that. And here are the fields that are included inside this JSON object. Now, if we wanted to use this schema or refer to it in one of the parameters or the response data types for this service, there's a special property here called $ref that we can use to call back to something in the definitions section. So that's important because you not only don't repeat yourself by defining the same schema multiple ways, but also in Swagger UI, which I'll show you in a moment, there's a nice area where we list each one of the schemas important to your service. So that's nice for clients to have. So let's actually take a look now at how to edit one of these things. And I can pull up Swagger Editor, a nice tool that can be used to do this. You'll notice there's two panes. The one on the left is the spec that we're editing in the JSON format. And on the right, we have something that looks like Swagger UI. So it's a what you see is what you get editor. You can kind of check your work that you're doing on the left-hand side. You'll see an error message if you have a syntax problem, or you'll see the representation of your service. So this is just very simple. There's one endpoint. It's the hello world service, because we're just going to return the message hello world. You can see some of that markdown syntax that I talked about here, this italicized word. And that's about all there is to it. So now we need to take this spec and get it into Iris so we can generate the code for our service. There's a number of ways to do this, but the one I'm going to show you right now is an interactive routine we created called $%rest. At the prompt, we're asked to enter the name of an existing service or list all the services that are already there. So I want to create a new service, so we're just going to type hello world. This is a new service, so we're going to say, yes, create it. And then we're asked to provide the location of the Swagger spec. Now, I've put this somewhere easy to find, so I don't have to type too much. And then we want to confirm. Okay, it says that we created 3 classes. Great. Now it asks if we want to set up a web application for this service. And we're going to say yes, because we want to use this thing. By default, it's going to choose CSP followed by the application name you chose, but I'm going to simplify that to just hello world. And there we go. The application has been deployed. Now, what happened? What did we just do? It said we generated 3 classes. Well, what are they? First off, the application name is going to be used as the class package name for these 3. If there's a conflict, the routine will let you know about that. But these are the 3 classes we just created. First, hello world.spec, which is simply a container for the Swagger spec we sent in. And when that class is compiled, we will generate code for the other 2. So first, the dispatch class, which in the code first design method, you needed to create yourself from scratch. But instead, we're taking care of all of that for you. Now, the functionality of your service, your own code, the application logic, will go in this implementation class down here. The hierarchy of that is such that when a request comes in to the web application, it's sent to the dispatch class, as it ordinarily would be. And then we call down into the implementation class, into a corresponding method. And this is where you are going to put your code. So let's just demonstrate that right now in Atelier. Is that big enough? No, the code will be bigger. I need to go and refresh the contents of my namespace. We have the hello world package here. I'm just going to copy these 3 to my project so we can take a look at them. We have hello world.spec, which is just the container for the Swagger spec, as I said. Over here in the dispatch class, we have our URL map. There's a comment here that was taken from the spec, from the summary string. And we created this method called test, using that operation ID as the name. We are setting the content type. This is the HTTP header for the response, because the service, or this endpoint rather, is set up to return plain text. We're next going to check compatibility with the client based on the request that was just sent in. And then on this 3rd line, we're going to call into the implementation class, a method called test. If I open that up, this is where all of your code is going to go. There's a stub method here that was created called test, and we have some comments to kind of help us with some of the things that we'll probably need to do, like setting status codes and the HTTP headers if we need to. But to fulfill our contract with the client, all we need to do now is return the string hello world. So I save that. And now, because my web application was created automatically, I can actually just go to Postman and make a request to the hello world address. And there's the string that we received in response. So now I want to take you through a more intricate example that will demonstrate some of the other capabilities of Swagger. It's going to be very complicated. It's going to have 2 endpoints when we're done instead of just 1. I'm just going to grab that to keep from having to type all of this stuff live. I'm just going to paste this from my text editor right into the Swagger editor. So you can see it's a service for a word game. Like, for example, we're setting up a mobile app, and we want to use a REST service as the back end. And one of the things we need to do with this service is to return the score for a particular word that was sent in. You'll notice for this endpoint we have $ref pointing at something called score in our definition section. And that's just a simple JSON object. It has 1 attribute, just an integer. We may want to expand upon this at some point. There's 1 parameter for this endpoint. It's a string. Comes at the end of the address. It's called word. These are all things that Iris will incorporate when it's generating that code for things like variable names and so on. Now, this particular service is already running on my Iris instance. I've already implemented the code for this endpoint. So I'll just show that to you in Postman again. If I send a request for the word test, I get a score of 4. I can try different words. OK, this one returned 5. And I can show you the extremely complex calculation that we use to arrive at the score for that word. But this is the key point I want to illustrate to you. This service is already functional with one endpoint. I'm going to add a second endpoint, and we'll see what happens. So again, I'm just going to pull this from the editor to save some typing. Here's our second endpoint. It's now a post request, where we're going to add a word to our dictionary. And in the Swagger UI view, you see the schema for the request payload is defined. That's also defined here in the models section, which is a representation of this area here, the definitions for our service. And $ref was used again to define the schema for that parameter. Now, I have one alternate way of updating the spec for one of these services that I'm going to demonstrate to you now. If you remember, I showed you the API management tool at the beginning. Well, we've expanded upon that for the Spec-first development capability. So we have API management version 2. If I make a request here, I get a shorter list of services. This is just the list of services that were created using the Spec-first approach, either through the routine or one of the other methods. And again, I can go into the Swagger spec address right here and return the spec. But what's different about doing things this way is that now, instead of generating the spec on demand, as we did before, by introspecting the dispatch class, instead we're just going to return what's in the spec class. So we're giving back exactly what was sent in. And this is important. This is an important distinction, because now you're encouraged to have a Swagger spec that is as fully defined as it can possibly be. When we generated the spec before from the dispatch class, we only had the information in the class available to us. But that's not the full extent of information that may be important to a potential client of your service. For example, I don't have that here, but one of the things you can provide in your Swagger spec is actually an example of each one of the parameters, or even the response data types. So rather than just saying, this is a string, you can provide an example of such a string that would be valid. Now, we don't do anything with that when we're generating this scaffolding code, but a client may find that very useful. Maybe they're going to generate a unit test based on that, or it's just helpful to see a real example of the data being sent to and from your service. Now, the reason I bring this up, this particular aspect of the service, is because this is how we're going to update the spec. In fact, I made a GET request to this address to retrieve the spec. But if I make a POST request to this same address and just take this from the editor, the very bottom there, it says application word game updated. So we generated new code based on the updated spec. Now remember, we had one endpoint that worked. Does it still work? Let's make a request to that address. And you see the score of 5 was still returned. And I can add a character to that word, and we get the correct value. If I take you into the implementation class, this has now changed, so I need to synchronize Atelier with the version that's on the server. Here's the diff report. I'm going to choose server copy because I know the server version is more up to date. And there you see we've added a new stub method for that new endpoint that was just created. But the original endpoint, the score method, was left alone. And this is the key feature of the spec-first development approach. It wouldn't work without this. We don't modify your code. You could even remove the score endpoint if you wanted to, if you were changing the way that was implemented, and we would still keep that method there for you. The only thing about the implementation class that we change is adding new endpoints. And if the parameters for an endpoint change, we update the method signature, but we leave a comment indicating that we've done so. It's a non-destructive approach to generative code. Just to summarize here, the reason that you want to keep your dispatch class and implementation classes separate is to have a separation of concerns, to keep the boilerplate code, the things like parsing the incoming parameters and setting response headers, separate from your application logic, which means that you can actually test the application logic independently of the way it's implemented as a REST service. So you have the ability to have more simplified unit tests that don't have to make requests to the service. When the spec is updated, we throw away the dispatch class and regenerate the URL map based on the updated spec. The implementation class, as I said, we modify that non-destructively. We don't change your code or even delete code as a method has been, or an endpoint has been removed or deprecated. As such, if you're keeping track of changes to this service using source control, which you absolutely should, the classes you want to check in are the spec and implementation classes, because the dispatch class is regenerated by compiling what's in the spec. So I hope this gives you kind of an appreciation for a different design approach, a new capability that we're adding with IRES 2019.1. I want to wrap things up here by just highlighting another way to update the spec. If you're interested in doing this programmatically, I recommend looking at the class %rest.api and this method specifically, create application, which takes arguments for the Swagger spec location, the application name, and even the web application name if you wanted to set that up. Some additional resources you may find interesting. If you're curious about creating a REST service using the code-first approach by writing your own dispatch class, the presentation I gave last year at Global Summit may be helpful to you. It's called Building Modern Web Applications, which I'm told is a little false advertising because it's mostly concerned with creating a dispatch class, creating a REST service. There's an online learning course setting up RESTful services, which you can take a look at, and also the developer community is always there, a way to look at examples that other people have submitted and connect with developers. Here's your reminder to please fill out the survey in the Summit app, and the recording and all the slides, and as I mentioned, the example Swagger spec and things will be available at learning.intersystems.com after the summit is over. And I will be in the Tech Exchange for the rest of the day and all day tomorrow if you want to come and chat about anything in the presentation. Thanks very much. And we have a microphone set up if anyone wants to step up and ask a question.
So that's all very cool. But I didn't see like the ensemble side of this. So are we going to be able to see, you know, in message trace and be able to see it like now if we use REST and that kind of thing? And for your XML, it's all cool because I can go look at the message and hey, that's great. But what are we going to do on the REST side of things and for JSON to provide that capability in the message trace and those kinds of things? And or should we be looking for those types of things going forward?
Do you mean different from the existing way of creating the dispatch class? Like, would you still be able to use the message trace with this, or do you mean with REST in general versus, say, SOAP?
Yes. Like, so, both.
Okay.
But like in being able to see it, like right now it's really easy for me to go look at the raw XML and messages going back and forth between everything. But right now that's not so easy with REST, right? Okay.
For these ensemble aspect of that, I can't speak to that as much in terms of the messaging automatically, like the IO trace and that kind of thing you're talking about? Right. So that I can't speak to. I'd encourage you to talk to someone maybe from Ensemble support in the Tech Exchange. But as far as the difference between the old way of writing the dispatch class yourself and now this approach, it's still a dispatch class. So if it would be possible doing it the code-first way, it's still possible to look at the message trace here. But I just don't know exactly how you get access to that information. So that's something the Ensemble folks can help you with.
I was hoping an Iris would see kind of the same kind of thing we see for XML.
So API management is a new tool you guys are releasing with 2021?
It is the concept, which is the REST service, the means to have access to the Swagger spec. I believe, was it on Monday, Jeff and Joe mentioned the full lifecycle API management would be available shortly.
So are you guys supporting, I saw you using basic auth, right? Do you support OAuth 2.0, or do you have any message analytics parts of it, like where you can see traffic coming through and how you handle encryption?
I think that's something you'd want to speak to Jeff Fried about to get the specifics. Anyone else? Oh, if you want to step up to the microphone, please.
It's really nice to see the separation between the display layer and the implementation layer. But we have in a REST API there are multiple routes, and if we want to have again a separation layer, means different implementation class for each route. Is it possible in this case?
Different implementation class.
Yeah.
So instead of having multiple methods in the same implementation class.
Yeah. So I have multiple routes, right, in the same API.
Yes.
So I want to have a different implementation class for that. So that
I'm not sure if that's possible.
So that, for example, there is an API called getPatient. I modify that. I don't have to touch the API, touch the implementation class for the save API. I want to separate being modularized in a further level.
Right, you want to have different classes for each one. I'm not sure on the specifics of that. There are certain Iris-specific parameters you can include in the Swagger spec, which, something like Swagger UI or things in the marketplace wouldn't do anything with. They just ignore, but those are important to Iris. There may be a capability there to have things split into multiple classes, but I'm not sure exactly what that would be. We can go try to talk to one of the developers in the Tech Exchange.
Yeah, I will.
Yeah.
Maybe what we can do, we can implement the business logic. We can put that in a separate class. So maybe that can do it.
Yeah, but we have to do it manually. But it is completely automated. If we can have some kind of configuration stuff.
Anyone else? Oh, do you want to step up? I don't know if this part's being recorded or not, but then everyone can hear.
How do you handle the JSON serialization for both the inputs method? Instead, right now you have a word, a string. What if we send an object? How do you handle that?
I believe, for the serialization, you would need to use the dynamic object API, which has methods like %from JSON and to JSON, to take the incoming stream and have that represented as an object, and then to return your response. You send back the dynamic object, and then we take care of the serialization back into JSON format. But was your question for other formats other than JSON?
For some hosts that we have to send a JSON to update the form, for example, change the signature of the method.
Well, the signature of the method is impacted by all of the parameters in the Swagger spec, so the types of response data that are being returned. I think you could configure that to have the stub method generated the way you want. But that's, again, we can take a look at that. The developers can speak to the implementation details probably better than I can. Is there one more?
Yeah. Are there any plans to support health share or cache with the new?
I'm not aware of the kind of long-term planning on this. Probably Jeff Fried would be able to answer that better than me.
Okay, thanks.
Okay, well, thank you again for coming.